On this circuit that's responsible for the timing, and you can see a tiny negative sign beside it. That means that that side needs to be connected to ground or negative.
A capacitor is a passive two-terminal electrical component used to store energy electrostatically in an electric field. The capacitor is the essential component of any circuit design, and in fact, after the resistor, it is the second most used passive component in the circuit. Now, these capacitors are available in various sizes and shapes, but the basic function of any capacitor is to store the electrical energy. And now, let us understand how this capacitor works. Now, this capacitor consists of two conductive plates, which are separated by a dielectric material. Now, this dielectric material is the insulating material, and it opposes the flow of the current. Now, before the application of voltage, the two conducting plates of this capacitor are electrically neutral. Now, if we apply a power supply to our circuit, for example a battery, the negative side of the battery will push electrons to this surface, and the positive side of the battery will suck out electrons. The capacitor will hold the same voltage as the battery after such long time of charging. So over the period of time, the right plate will have a shortage of electrons, while the left plate will have excessive of electrons. Or we can say that the right plate will get positively charged, while the left plate will get negatively charged. And because of charged particles, the potential difference will get developed across the two plates. Now, the building of charges across the two plates will continue till the point the potential difference that is developed across the two plates is equal to the supplied voltage. And because of this potential difference, the electric field will get developed across the two plates. And this developed electric field is directly proportional to the potential difference, and it is inversely proportional to the distance between the two plates. So smaller the distance between the two plates, the stronger will be the electric field. So in this way, when we apply the voltage to the capacitor, then the charges are developed across the two plates of this capacitor. And because of the development of the charge, the electric field is developed between two plates. So in this way, the capacitor stores the energy in the form of this electric field. Now, even if we remove this voltage source, then also the charges that are developed across the two plates will still remain as it is. So as you can see here, the wires are connected between the two terminals of this capacitor, and load in the form of bulb is connected to this conductive path. So whenever we attach the wires to the bulb, the electrons from the bottom plate will get attracted towards the top plate. In this way, you will see the transfer of charge or flow of current through this conductive path. So now, because of the flow of current, you will see that the bulb will glow, and in this way, the current will flow through this conductive path. And this procedure will continue till both the plates will become electrically neutral. And because of that, the bulb will again turn off. The capacitor acts as the storage tank and stores energy. It can release this to smooth out interruptions to the supply. If we turn a simple circuit on and off very fast without a capacitor, then the light will flash. But if we connect a capacitor into the circuit, then the light will remain on during the interruptions, at least for a short duration. On the side of the capacitor, we will find two values. These are the capacitance and the voltage. We measure capacitance of the capacitor in the unit of farad. The other value is our voltage, which we measure in volts with a capital V. The voltage value is the maximum voltage which the capacitor can handle. If it's too much, it will explode. Hope you guys learned something. See you in next video.